So let me go ahead and start recording this. So here's what we've got so far. So to solve it, so this is the rest of the solution. For int I is equal to 0, I is less than rest of word length. So what we're going to do is that basically if there's n factorial combinations. So if we're looking at the first letter, we're going to lock that first letter into place. Basically, if we're looking at the first letter of what we're trying to generate, of the permutation we're trying to generate, we're going to lock that letter into place, and it's one of n letters. And then we're going to find all the permutations that we're going to print out all the permutations for of that letter and the rest and the permutations that start with n-1 letters. I know that didn't really. Sorry, I kind of butchered that explanation. Let me go ahead and. It's easier to see in code. And then I can explain it once the code comes into play. Okay, so this is what I meant when the code is really short, because all you need is just one call over here to permutation again, and we'll do current perm plus rest of word dot car at I, and then I'll put as a comma here, and I'll put it over here, and then rest of word dot substring 0 dot the ith one plus word substring 0 I plus 1. Yeah, that's all we need there. So that should work. And the idea here is, okay, so like I put on the board behind me, if I've got 5 letters, the first thing I want to do is choose one of those 5 letters and lock it into place. So I want to go through each of those and lock it into place as my first letter. Okay? And then I want to figure out all the permutations with the rest of the letter, with the 4 remaining letters. Okay, so I'm going to call basically, so this is going to start with S, and then the rest of the word is going to be team. Okay, and then it's going to, so that one we'll call basically, so here current firm will then be S, and rest of word will be team. It's not the base case, so for every letter in rest of word, so we throw T, so the current permutation is ST, and then the rest of the word is EAM. And then it will generate, so it's going to go through all those recursive calls, is what it's going to do, is it's going to generate steam, and then STAEM, and then basically it's going to go through every single permutation, right, can be defined as choosing a letter and locking it into place, and then the permutation of all the other letters. And do that for every single letter. And that's exactly what we're doing here. So questions, anybody, about this solution? Because it was a bit of this one's a tough one. It's even a bit hard to explain. Can I run it? Don't believe me? See, I'll copy paste it into here, where I did it yesterday. I mean, and then here's the permutations for hello. Oh, editor does not contain a main time. Oh, right, because it's in this class that's not. Okay, so let me go ahead and create a new class. Testing perm, create a void method. Okay, and then I'll just copy, and then again I'll copy paste these into here. Okay, and then permutation. So there's all my permutations of hello. It did hello first, and then hello, hello LL. Then it did hello again. So why did it do hello twice? Because let's call this one L1 and L2. This one was HEL1 L2 O. Then this one was HEL2 L1 O, because right, it repeats. You've got repeated L's. So right, I generated all the words. So first, I generated all the letters that start with H. And then to figure out all the permutations that start with H, I generated all the permutations that start with HE. Then I generated all the permutations that started with HL. Then all the permutations that start with HO. Then all the permutations that start with HL again, right? It's because we've got two L's, okay? To generate all the permutations that start with HE, well, I figure out all the permutations that start with HEL, all the permutations that start with HEL, and all the permutations that start with HEO. Make sense? And then for E, to generate all the permutations that start with E, I figure out all the permutations that start with EH, then EL, then EO, and EL again, right? Because L appears twice. So, so that's basically all how. So you can kind of see the recursive process that goes into building this. This one's a tough problem. It's an annoying problem. It's a pain in the butt, actually, to be quite frank. Yes.
How does it shift between H and E and like?
Yes.
Does H first
How
and
it
then
goes
goes?
from first letter to
How does it go from the first letter to the second? Well, because we're building it up from one thing at a time. So it all happens in this for loop, right? The first argument is, so basically, if the rest of the word is blank. In other words, there's no other things to add to the here what we're doing is that we're building a permutation with this function, right? We're building a permutation, and we're going to print it out as we build it, okay? So we're going to print it out when it's done being built. For it to be a permutation, we have to basically make all the letters have to be in it, right? Which means that nothing can be left over, which is what rest of word is. So if rest of word is equal to 0, so if there's nothing to build a permutation from, we print out the permutation we figured out. So once we've gotten rid of all the letters and add them to our permutation, we're done. So if we haven't figured out all the permutations, if we haven't put all the letters into our current permutation yet, well, there's a bunch of ways that could happen. We could put the first letter of the remaining letters and add that to our permutation. We could take the second letter in the rest of the word and add it to our permutation. We could take the third, the fourth, the fifth, or the sixth, and that can be added to our permutation, right? All those are valid choices when we're building a permutation, right? If we're starting with, with hello, or rather, let's go with steam again, because that one's easy to, that one has no repeated letters, right? We've got STEAM, right? So say we start out by basically saying that that we've got blank here and we've got steam here, okay? So we aren't at a base case, so what do? Well, we look at what we're going to do is that we're going to say, okay, figure out all the permutations that start with S, and if we're starting from S, then all the rest of the letters are going to be T, E, A, and M. Okay, and once that for loop is finished and all those recursive calls finished, I'm going to call it on T, and then it's going to be S, and then it's going to be seam as the rest of the letters. But going into the call with regards to with S and then the rest of the word being team. So suppose we have S here and team as the rest. In that case, what's going to happen? Well, we're going to go through each of the letters of team, right? So all the possible permutations that start with S, they'll either start with S and T, or they'll start with S and E, or they'll start with S and A, or they'll start with S and M, right? And that's what happens. We go and add each of those letters to the rest of the permutations and say, okay, the remaining letters are in S and T, they're going to be EAM and all the permutations, and then we'll figure out all the permutations of those three letters. Or it's going to be SE, and we'll figure out all the permutations of those letters. Does that make sense? Does that clarify matters? And so the way the computer does this, or the way we did that with our computer, is that we basically said, I'm just going to choose one of these letters, I'm going to lock it into place for this iteration of the loop, and then I'm going to take each of the rest of the letters that are left and figure out where that will, how I can how many different ways I can add those to the remaining letters, right? So this algorithm is actually will take a very long time to solve. Okay, right? This I'm still in the A's here, right? This is how many letters? 1, 2, 3, 10 letters, which means there's 10 factorial different combinations to print out, which is a very big number, right? So AJ, and then it should AK, right? And so now we'll in the B's. So basically it will take that long to finish. Yes?
How is it switching current perms?
How's it switching current perm?
Yeah. There's no like I
there's a caret I over here, right?
And that makes it switch from like S to T.
Yes, right. For the in the up level, it switches it from S to T, right? Because we start out with permutation being blank and the word being like ABCD, right? And then we're gonna so it's gonna start. So it's going to be empty string plus A, then empty string plus B, and then empty string plus B, and then in the call where it's A, and then we've got BCD over here, it's going to be A plus BC. It's going to be A plus A and B, and then CD, or A and C, and then BD, right? So that's how that one works. So what we're going to do is yes.
The substring with 0 to I. So how's that one work?
How does this work? 0 to I. So we're grabbing the ith character, right? So the rest of the word is going to be all the letters before the ith character and all the letters after the ith character, but not including the ith character, right? Because this is up to but doesn't include the ith letter, and this is all the stuff after the ith letter. So, all right. So what we're going to do is that we'll take a break here, right? If you guys need to. If you want to basically stretch your legs for 5 minutes, we'll come back, and then we're going to get started on the next chapter.